All right, we're going to go ahead and get started. Ladies and gentlemen, good afternoon. Sorry about that. We are in Vegas. This is a little rough. My name is Ryan Campbell. I'm a senior SharePoint consultant for Microsoft. Today, we're going to talk about advanced performance analysis for SharePoint. We're going to discuss the holistic approach to identify where potential bottlenecks are for SharePoint. I'm going to give you guys the strategies that you can employ today, regardless of what version of SharePoint you're running, be it the old STS, 2007, 2010 to 2013. This session is really geared towards on-prem large enterprise environments. A lot of value you can take away if you have the small environments, really looking a little above 100 gigabytes before these things start becoming a major player. Have you know that I really didn't say too much about Office 365. This is really on-prem stuff. For our objectives, we're going to introduce Contoso. Half this presentation is going through a case study. Then we have effective performance analysis, and I'm going to introduce you guys to the performance pyramid, where we broke out all the possible bottlenecks for the environment. We're going to go through the traditional tools that people usually use for performance monitoring, very high level. We're going to identify where those gaps are and how they fall into our performance pyramid. And then we're going to discuss Contoso strategies. At the end of this presentation, I'm going to try to save 10 or 15 minutes. I'm assuming there's going to be a lot of questions, especially since we got standing room only. People are starting to really enjoy their performance metrics, apparently. So Contoso, I know you guys have heard quite a bit. Contoso is a real-world customer due to NDAs and things like that. We really can't share who they are. They are, we aggregated data for about 2 weeks. They're a 12-server farm running on SharePoint 2013. 35,000 users are interacting with the SharePoint environment, running about terabyte and a half, terabyte and 3/4 worth of data. They have 2 data centers, one sitting in DC and one sitting in Austin. Actually helped these guys set up their high availability. We'll talk about another time. Effective performance analysis is really about gearing all of your investigations and tools to get back to the end user experience. If my clicker will work, please. There we go. In all versions of SharePoint, speed is a common complaint. Users will permit up to 5 seconds. After that, you start getting tickets, phone calls, VIPs, sending you text messages, whatever the case may be. The goal for all your performance metrics should really be about 3 seconds. The user's reference is only internet browser. They don't know anything about the RAID levels in the SANs. They don't know anything about processor web front ends. They don't know anything about the number of app servers or when you're running backups. And frankly, they shouldn't have to. This is what our job is here as SharePoint engineers, to identify where these things are so that we can empower our users to utilize SharePoint in the way they're expecting. As such, all of our testing needs to get back to those end users somehow in some way. So here's our performance pyramid. Seems very simplistic, that's the idea. Starting at the very bottom, we're looking at server performance. When we're talking server performance, we're going to look at disk latency, we're looking at RAM, we're looking at number of processors. These are known quantities that we can pull straight off of TechNet and off of best practices. Coming up next is configuration. This is really where the software-based adjustments and tweaks happen in both SharePoint, SQL, and IIS. Up next is traffic. Traffic is looking for things really as an objective and unbiased view on what's going on in your environment. For example, if you have one site that's the CTO's blog, and hands down, it's the most important site because it's considered VIP, and you're getting phone calls that say the site is slow, the site is slow, the site is fast, the site is slow. The idea with traffic is to go and look to see not only is what's happening with that page, but to analyze everything else. Maybe you have another user banging on your SharePoint site at that different time. This tier is going to help you identify those things so that you can be empowered as a technical user to have that information and slice as to what's happening in your environment at any one time. Up next is LAN and WAN. It's exactly what you guys think it is. It's making sure that we have the capacity on both the LAN and the WAN getting out to the internet for our end users. Here we start looking at things like throughput. We start looking at congestion. We start looking at load balancers configured correctly, and we even start playing with some branchcast and CDN technologies. Last but certainly not least is the user tier. I put it at the very top because each one of these individual items will impact the user tier. User tier really discusses the OS versions. It's really taking a look at the individual machines to see how they can load SharePoint all by themselves. We all know that the latest internet browser versions are going to work with the latest versions of SharePoint much better. But if you start floating around IE5, IE6 against SharePoint 2013, we're going to have some long load times. So identifying where those users are to make sure they're not skewing your results are critical before any type of performance analysis. Once that pyramid is fully realized, it enables us, excuse me just one second. Apparently there was an update last night. Sorry about that, guys. When you put all the pieces together for the performance pyramid and understand what's happening on your environment, we can infer what the end users are experiencing in bulk. Using some of the new BI features, we can start doing things like this. Before this thing gets started, we're going to go through 3 quick screens. The first screen is going to be individual user locations for a particular day. This is Contoso. This is real-life data. If you watch carefully, on the right-hand side, right around 8 o'clock in the morning, surprise, surprise, things starts waking up, working your way to the left. As we get down towards 5, 6, 7 o'clock Eastern Standard Time, things start slowing down. I'm going to go ahead and pause it right there. The most important thing I want to show you right now is at 11 o'clock at night, we are still getting traffic on the SharePoint farm. When I went to Contoso and told them this, I said, hey guys, you are still lighting up in the middle of the night. What is going on here? Why are you doing this? They were surprised. Taking that, then we can also aggregate what's happening for the load times. As this thing is loading, anything over green is considered bad. Let me just pause that real quick. Let me ask you real quick, where do you think the problems are? Pretty easy, right? Right there in Baltimore, D.C., guess where the data center is? Baltimore, D.C. That's a problem. We eliminated the WAN right then and there. We have some issues here in Augusta, some over here in Austin, and Seattle's going to start lighting up here in a minute, and San Francisco is also running a little long. Looking at it this way, we're able to make actionable decisions across bulk information coming from little more than logs and analysis that we're going to talk about today. As we continue to run, you can see clear into the night at 8 o'clock, Baton Rouge was still running pretty red down there, and things start tapering off. Combining those two together, we're looking at individual user counts on the column chart, and we're looking at load times. It's a little hidden right there. We got Austin, that's a little busy down there, over here in Georgia. Right there, ladies and gentlemen, we just together, in about a minute and a half with me talking, looked at 75 gigs worth of logs, analyzed it, crunched it down, and everybody sitting in this room just saw where the problems were in that amount of time. Now we're going to talk about the traditional tools and how those traditional tools play into each individual tier in the performance pyramid. Very top one, near dear to my heart, Performance Monitor. I love Performance Monitor, but let's face it, it has some serious gaps. One of the biggest problems Performance Monitor has is it doesn't tell you a threshold versus what's acceptable. If I'm looking at Performance Monitor, hands down, if a processor's running at 100%, that's easy, right? Server's overloaded. But what if the processor's running at, I don't know, 30%? What if it's running at 60%? I don't know. Nobody else is going to know looking at just this individual tool, and you can't correlate that back to your end user response time. The other thing about Performance Monitor, excuse me, the other gap with Performance Monitor comes when you start looking at large amounts of data and comparing multiple servers. Anybody who's played with it knows that Performance Monitor has to redraw every time you change and move those counters around. So when you're looking at, I don't know, 5, 6, 7 hours, becomes a long, lengthy process. And when we want to start talking about weeks at a time to see what is happening in the end users, becomes a significant challenge. Click. There we go. Thank you. Load testing also kind of flirts with server performance and configuration, falls on both sides. Load testing is a critical tool in any analysis in any type of new farm environment. However, it too has some problems. First and foremost, load testing is not really long enough, and it's difficult to accurately represent what's happening with your end users. Sorry, I thought he had a question. That's okay. Load testing is difficult to represent what's happening on your end users, and your user hardware is not accurately represented. At the end of the day, when we're running load testing, it's usually on dedicated servers, just dedicated desktops. May not necessarily be the 1 gigahertz Windows XP machine that a lot of the users are using. Load testing is great for pushing SharePoint and pushing the environment to the point where it breaks, but it's not really good for doing cross-traffic comparison. It's not great for comparing what this page is doing compared to this other page when real users are accessing it. Browser timers. Real quick, can anybody tell me what version of IE that is? That's right, thank you. One of my favorite new pieces in IE 11 is the browser timer. All browser timers suffer from the same problems. They're very difficult to run bulk data. When you start talking about 10, 15 pages, that becomes feasible. When we're talking about 20, 30,000 pages sitting in SharePoint and trying to identify where the bottleneck is, these type of browser timers are just not up to the task. It's not what they're designed to do. It's also difficult to measure the server impact. When we're looking at this one page, and we pull this up on our development power machine or whatever the case is, we can't see what's happening on the web front end. We can't identify what's going on SQL, and we certainly can't look at the SAN, things like that. But we can still aggregate this back up to what's happening on our individual browsers. Browser timers also don't consider that cross-site traffic. We're looking at one page. If another page is impacting the environment, or maybe we're impacting them, we're unable to see it with this type of tool. Network sniffers. This is Wireshark that I showed here. Network sniffers are pretty much all the same, looking at traffic going back and forth on the wire on the individual machine. Suffer from a lot of the same problems of load testing. They're very noisy with non-SP traffic, and it's difficult to scale between 2, 3, and 4 machines. Looking at the different network paths, it's also difficult to correlate to a performance monitor and understand what's happening on the servers at the same time. This is great for measuring what's happening on one machine, but not necessarily across the entire enterprise. Looking at all these tools, summarizing it up, on our user tier, we have no true bulk analysis, and we don't have any version comparison. Looking at different browsers is complicated when we eliminate the. Next is LAN and WAN. We don't have any real WAN analysis. There are some tools out there that we can reach out and talk about the routers. We can look at the switches, things like that, but we can't specifically make it down to SharePoint. There's no traffic analysis, and there's no architecture checks on the configuration. At the very bottom, server performance, we don't have any thresholds identified. The most important thing that I want to stress to you about the traditional tools and using them in a vacuum is you're really focusing on the details without looking at the bigger picture. SharePoint is a much larger beast, as we all know, than just running web front ends and looking at processors and looking at load balancing. So we're going to talk about Contoso now. We went out to Contoso. We introduced this performance pyramid to them. We said, hey, guys, we want to do a case study on you. We know you're having some problems. We broke down each individual tier with Contoso, and we identified how we're going to meet that need in a bulk way, always rolling up back to the user's load time. At the very bottom, we decided to run Performance Monitor, but we output it as a CSV. We'll talk about why that's critical here in a minute. Using it as a CSV, we're able to quickly ETL it into a database. Configuration. In order to understand what's happening in SharePoint, how it was set up, how it was built, we ran enum webs. We ran SPS Farm Report, which I'm sure you guys are aware. That's a free CodePlex project. And then we loaded all the ULS. Within the ULS, we were looking pretty much for things like the high, the critical, notifications. things that would call out to us that SharePoint is not operating the way we expected it to. For traffic, we rolled up the IIS logs. So each individual page with SharePoint has a number of artifacts it has to request, including images, CSS, things along those lines. By rolling those up, we're able to mathematically aggregate what those pages are doing and how long it takes for the individual browsers. Then we added what's called the exported for header. Does everybody in here know what exported for is? All right, I got like 5 people. All right. Exported for is a standard header that allows the load balancers to append the client's true IP address. If you're looking at IIS logs and you're looking at the client IP, 9 times out of 10, it's going to be the load balancer, especially if you guys are running ACEs, F5s, things along those lines. That's because the request is actually being rerouted from the load balancer. Using the exported for, we're able to get to that true client IP address as well as any proxies that it has to get to. Rolling up to the next tier, going to LAN and WAN, we took the IIS time taken, which is a measurement of how long the request took to get down the machine and the acknowledgement to come back. Then we also combined it with the client to server and server to client bytes. I'm sure you guys can see pretty quick what we are able to do in just the logs is calculate the throughput that the end user is seeing on the network to get from the web front end all the way to their machine. Then to make it more fun, we took a trace route from the individual web front ends to each one of the clients and built a network map. Comparing all those allowed us to aggregate the data back into the individual network paths and identify where we were having slow and saturated links. We'll talk about here in a sec. For the user, to determine the different OS and IE browser versions, we just looked in user agent. This is straight out of IIS logs. And then we were able to calculate, based on their IP address, where their physical GPS location is. And that's what you guys were looking at with that video. Different customers are going to do this differently. These guys actually had a subnet, network map that allowed us to calculate where they were. For 2 weeks of data, we are talking about a ton of data. This took forever. 400 gigabytes of data this thing took for a little more than 12 million hits on IIS. Performance Monitor was easily the lion's share of this. We took 8,500 data points every 5 seconds from each one of the servers. Now, we didn't necessarily need 8,500 data points at the very end of the day, but we wanted to make sure we had that data to slice it and get down to what we needed to. This was more an insurance policy to make sure we could see what we wanted. Worst thing that could happen in this scenario after we went through all this work is we forgot to see what the processors are doing or something silly. So we just grabbed it all. For our IIS logs, we're looking at 22 million hits. Now, a hit is just an individual request that is hitting IIS. So if a page has 5 different images, that's actually 6 hits. It's going to be 1 session we're talking about here in a sec. Turned out to be about 18 gigabytes of data, give or take. Traceroute was kind of a unique challenge. We had 3,500 unique hops getting from the individual web front ends all the way back to the servers. Some unique things happening in some of the commercial internet providers where things were going in loops, so we had to set a max of 10 hops. Just be aware of that if you guys are using these same strategies. At the end of the day, we're looking at 36,000 users, 25,000 pages, and about 14,000 sites. Sites as in SP webs. No, SP webs. Yep, individual sites. Site collections is about, I believe it was 2,500 sites. Site collections, I'm sorry. Now that we understand the theory, we know what Contoso is doing, we know overall how this is happening, we're going to start getting into the weeds. We're going to get down into the details on how Contoso was able to get value out of this. One of the key things when we walked into Contoso is we needed to keep our costs down. We needed to make sure that we weren't using any kind of exotic Azure machines or some kind of $10 million SAN to move all this data around, things like that. So our strategy really resolved around my individual work machine, and that's it right there. It's a 15-inch laptop with an i7, ran 32 gigabytes of RAM. The only, can you guys see that? There we go. The only important thing that I have to stress is the SSDs. When we're slinging 400 gigs of data around, when we're talking about SQL Server, when we're playing with cubes, things like that, on this type of machine, we got to have the throughput, we got to have the IOPS. These SSDs were SATA 3s. They gave us about 500 megabits per second across each one, and then we did some magic to make sure we could use the entire thing. Regular old Windows 8.1 Pro, Hyper-V, we had 4 guests. Guests were really a DC, a SQL Server, and a couple of dev machines so we could light up the processors. For tools, we kept it to simply what we would see in the environment for anybody running SharePoint 2013. We had SQL Server 2012, we had SAS, Excel 2013, the new Power Map preview, which is what we used to create the video a little earlier. And then, of course, we had Visual Studio 2013 for some of our ETL tools. Zoom in right here. The key factor to bringing this all together and making the data in such a way is building our database. And this, hands down, is the linchpin on how we were successful. Sessions were essentially our IIS sessions rolling up, correlated to the individual performance counters that we got from Perfmon. Loading them in a database like this, we were able to directly measure the impact of a request to what's happening on the servers and take into account all the other requests for that time. Here in a minute, you'll see how we took this database and created graphs in Power BI and Excel. Sorry guys, my clicker's not working. Using this database, we were also to aggregate our network paths and calculate our throughput. We had some significant challenges trying to load all this data. First and foremost, on the IIS side, we had a hard time aggregating our individual hits, roll up into sessions. What I mean by that is taking a default.aspx page, or whatever the case is, and adding all the other requests associated with that to infer what's happening on the end users. So for example, if we had one page and we had 5 different images and CSS, things like that, in IIS, we're able to measure what's happening for each one of those requests, but rolling them up across a large section was significant. To pull that off, what we did is we tracked the client IP address, we tracked the CS refer, and we tracked the user logon page. And then we went back to the previous request and looked at the anonymous access to make sure we were getting that third request coming through. Now that we had the sessions rolled up, we had to correlate them to our SP webs. To be honest, we did little more than brute force at this point. We took all the individual unique requests and started chopping off the end of URLs until we found a matching SP web from our enum sites report coming out of SCS admin. For our 25,000 pages, it took about 15 minutes to run that. It took us about 5 minutes to create the cursor. The biggest problem that we ran into and we had to keep fighting was just the pure speed. When you're talking this amount of data, 18 million rows sitting in just IIS. By the time we were done, we got it down about 4 hours to load all this up. We wrote some custom ETL tools sitting in Visual Studio, multi-threaded it, did a lot of bulk copy, things like that. Performance monitor. This is my personal favorite. This was quite a little puzzle for us. For my SQL DBAs out there, we had 12,162 rows, or I'm sorry, 12,162 unique columns spread across all of our servers. Real quick, what's the widest table you can put in SQL Server? That's right, 8,500. Thank you. In order to get this to fit in our SQL database, we had to normalize our data on the way. As we were enumerating through our environment, we had to put it in third normal form and set it up for compression. This ballooned our total row count up to 24 billion rows. Insane. It was enormous. Hands down, speed was still a problem trying to get all this data in. That poor little laptop of mine ran for about 18 hours, fully loaded in order to get all this data in and aggregated the way it was supposed to be. I actually burned up 2 RAM chips because of it. That was fun, right in the middle of that. Yeah, that was a difficult conversation. Hey, Amazon Prime, come on, get it tomorrow. So after about 18 hours, we were able to get all this data loaded and then, of course, back up our database. Our database ended up being, at the end of the day, a little over 100 gigs via compression and using third normal form to get the repeated data down. Now that we understand how it loaded, we understand the challenges and how we accomplish those challenges, this is where the real value comes into play, ladies and gentlemen. This is where we went back to Contoso and said, here's what's going on in your environment, and here's how we can compare to see what's happening. Typical day in Contoso, we actually picked January 2nd. As we're looking across the environment, we were able to compare and see, make sure that this day was pertinent and a realistic representation of what's happening. If you remember earlier, we're really looking at about 3 seconds. Anything over 5 seconds, people start complaining. When we showed this to Contoso and went, you guys are getting phone calls, obviously between 10 o'clock and 3 o'clock in the afternoon, they went, yep. But when we load up the page, everything is fine. We don't understand what's going on. Here's what's happening. These are individual real users. As the users start warming up throughout the day, this is local standard time. We can obviously see some pretty easy spikes coming up. When we talk about measurable performance and we talk about metrics we can actually look at, these are the kind of things. We can recreate this graph fairly easy, understand what's happening in the environment at any point in time, and adjust our infrastructure, adjust our code, whatever we need to do, and compare it against this. We also have some pretty big anomalies. This is my personal favorite. Right here, this little guy right there. What that's telling us is the number of our sessions started to drop off at about 2 o'clock in the afternoon local time. But our load time was still going up, peaking up almost to 9 seconds. And the most interesting thing is when we had higher sessions over here, we had relatively lower times. When we're looking at the data in bulk and we're making those objective, unbiased approaches, these are the kind of things we're looking for. Looking for these anomalies tells us that we have a problem that's not necessarily load-based, but something is happening on the environment. We'll talk about what actually happened here in a second. Over here, this is another anomaly. Sessions continue to go down. Average load time started going up right around 7:30. When I showed the original video to Contoso and said, hey, do you guys know that a large part of your traffic is still happening around 7:30, and your load times are getting much too high, they're getting back in the red? Did you know that? They had no idea. Looking at these different graphs, going through this performance, now we can start walking up our performance pyramid to understand what's happening in the environment and where the individual bottlenecks are and where our problem childs happen to be. This particular graph is the amount of RAM available to all the servers. These top two were app servers. These bottom four were web front ends. As you can see, we're a little under, that guy right there I think was about 750 megabytes of RAM. In order to solve this, what they were doing, let's go back one slide. In order to solve this, what they were doing is right around 2 o'clock in the afternoon, RAM would start to peak as users would come in. They had instituted an app pool recycle at maximum memory, thinking it would help them in the morning and in the afternoon as they were crawling their backups. What really happened, people started using the environment, and then all of a sudden our load times were spiking. We also identified they were only running one temp database. It was a mistake when the servers were rolled out. They had 3 different SQL servers running in the background. This one temp database also happened during the crawl, this one SQL instance with only one temp database was hosting their crawling environment. So putting a real hamper on what's happening with the rest of the crawling. And then we had some host affinity issues. And host affinity, I'm talking virtual machines here. They were running 4 physical blades, had all 12 servers spread across. But as we were looking at Performance Monitor, we started to notice that the pages per second and memory and spikes and latency and things would all start grouping together with the servers. So we were able to infer that our guest machines were not spread evenly across our physical hosts. Went back to the infrastructure team and set that straight. The action items that Contoso took away from this were RAM. SharePoint loves its RAM. Told them to double RAM. They actually came back and said, well, how about we triple it? We got to about 24 gigs. Fantastic. Overnight, started waking up. SharePoint, the response time dropped about 30%. We went back to temp database, ran some quick T-SQL, created 8 temporary databases. That's in line with TechNet best practices. Files. Yes. Yes, I mean files. Host affinity, we spread our VMs across our physical host. That also helped. And then we set our max stop to 1. Is everybody familiar with what max stop is? Parallelism in SQL Server, right? The idea is that SharePoint does a lot of small transactions, and the cost of parallelism, it is negative in that environment. If you're doing large data sets, parallelism is your friend. SharePoint, no. Set the max stop to 1, get rid of it. Moving up into configuration, what we started looking at here, this is network traffic coming in and out of SQL Server. What had happened is their search topology was set up incorrectly. So these are SQL Server indexes. There's a gray line that's really hard to see that's lined up with it. There's a little bit of the gray line. There's a little bit of the gray line. What can I say? I'm SharePoint, not a report guy. Sorry about that. What was happening here is they were running their search in the middle of the day, right after they were taking their ECM solution and pushing thousands of documents. Their ECM guys were pushing right around lunchtime because they knew it was a low time. And then search, whoop, that would be the wrong button. Then search would come back and hit it and find all these documents. App pool recycle was also set to run with max memory because they had such a hard time with the web front ends running out of memory. We were able to turn that off. Second configuration, blob cache and page cache. SharePoint loves its cache. It needs memory to do this. This was another symptom of low RAM. What Contoso did in this scenario, and this was several months ago, excuse me, what Contoso did by setting blob cache low and turning off a lot of their page cache was trying to preserve their memory. As opposed to addressing the problem, we addressed the symptoms. We identified all that stuff happening objectively and unbiased, came back, we're able to rip that stuff out, give it some RAM, turn these things back on, let SharePoint do what it wants to do. For the configuration tier, several action items coming back for Contoso. We had to redo the search topology. We changed it from 3 different index partitions with offline query components to just one straight across the board. They were only running about 5 or 6 million documents. We increased the blob cache sitting in the web front end 10 times, give SharePoint a little bit of room to breathe, let it start using the RAM that it has, shut down the application recycles. Then the network traffic, we went back. Let me bring that back up real quick. Right here, this nice little network spike happening at about 5:30 and continuing well into the night. That's backups. Went back and said, Contoso, you guys are running a lot of activity and traffic throughout the night. You need to start postponing your backups so we're not impacting those users. Moving up to traffic, this is where the rubber really meets the road. This is where we were able to take all this data, compare what's happening on the environment, understand what's happening with the individual users, and looking at it unbiasedly and objectively. We took the top 25 sites based on just pure traffic and user sessions and plotted them out to see where our averages were getting skewed. Now, the most important thing you see here, if you remember, 3 seconds is right about here. Halfway down, this is 4 seconds. This is 6 seconds, right? Yes. Most of our sites are still getting underneath that SLA where we want them to be, under the 3 seconds. But our average load time for 2 sites, our help desk and the ABC GC big site, those are fake names, I'm sorry about that. They're well in excess of where we need to be. But the interesting part when we start looking at anomalies is this blue line here is our, the gray line is our unique user count. So for some reason, we had 60% of all of our traffic existing on this one site to one user. That was very interesting. Coming back, we told Contoso, did you guys know this was your most important site? 60% of all your traffic, right? 22 million rows, 15 and change of them are coming from this guy? They had no idea. This is where the objective unbiased is, where we can go back and address where these problems are and determine, first of all, is this accurate? Is this the way it's supposed to be done? Or is this somebody who just flipped a switch accidentally and forgot to turn it back off? Coming next, they had a help desk site that was exceeding our threshold all by itself. We were able to identify and look at the individual pages, see what was happening, go and tell. Not only were we able to tell Contoso this is a problem site and affecting all of your users, but where the different web parts were in the individual pages. These two anomalies here allowed us to come back and, excuse me. These two anomalies allowed us to come back to Contoso and tell them where the user session time versus the user load time was disproportionate from the rest of the environment. You see it has a nice little spike there and has a nice little spike there, but we're not really running a whole lot of users. This particular site had a lot of closed web parts, but they weren't removed. So we went back and cleaned that up. This site had, it was not published, if I remember correctly. So it's not taking advantage of the cast and doing a lot of loops back and forth. When I went and asked Contoso, I said, what do you guys think your most important site is? You know what they told me? I don't know. Wasn't on this graph. This is where the real value is. They came back and said, we don't know what our most important site is. We just know that we're getting a lot of phone calls about it being slow and it's all over the place. Most of their slow phone calls came from the help desk, came from this particular site here. 90% of their traffic existed across these small set of sites. This is where the focus was and where we put a lot of our effort to identify what's happening in the environment. As opposed to concentrating on this 10%, while it's important, it's not really a lot of bang for our buck at that point. Action items coming across, looking at different traffic. This was the user that was hitting the environment. RG1 was region 1 and had some special pin code. We went back and asked them why they were accessing this environment, and we needed to reduce or eliminate it. Overnight, we were able to remove 60% of the load to their entire SharePoint environment, clean up their cache, and performance started just going through the roof. What had happened is a bunch of load balancer guys were testing some new scripts or keep alives or something like that. Apparently they had 3 or 4 environments, they were all using the same code, and they pointed at the production SharePoint site and forgot. Yeah. To make it even better, when we went and told the load balancer guys, hey guys, 137.846 is your code, it's beating our farm, they told us, no it's not. Yes it is, here's the logs, had to tell them the IP addresses. It was quite the interesting conversation. It took 3 or 4 things. But having that data and having it loaded in such a way that we can give them empirical anecdotal evidence without this opinionated finger-pointing thing that happens a lot of the time was really key to get the environment working the way we wanted to. Last action item was identifying the slow load times. We saw a lot of BCS connections. We saw a lot of sandbox solutions that people had just kind of ripped together, things like that, that they hadn't addressed before going to SharePoint 2013. That was slowing down some of the rest of the environment. This is my personal favorite. This is the network map. This is SharePoint up in the very top. For lack of a better word, because the network map was so big, I didn't have anywhere else to put it, so that's where I threw it. Each one of these yellow lines was a throughput that had more than 50 sessions, had more than 50 sessions going through that network path, but we had less than 250 kilobytes of capacity. So I'm sure you guys are familiar, dial-up 56, right? You go home, you get a megabit, those kind of things. So here we're talking 4 or 5 times just dial-up from the old 90s. The red path is less than 56 kilobytes throughput happening here. A lot of our regions, remember in the video where we showed we had Austin, this was actually Austin here, and then we had a problem in San Francisco. This is the San Francisco cloud right here. To build this graph, we use our database, and then we use a tool called Node XL that's free off of CodeFlex. Showing this type of graph to the network guys, their first question was, yeah, we know about these guys right here. We know that's happening. There's a lot of YouTubing, people looking at cat pictures, silly stuff like that, and they're eating up all the network. The San Francisco and Austin guys were kind of a big surprise, went back and had to adjust those and bring it up. Value comes out of the action items we were able to identify for Contoso. We told them what slow links on their WAN that they needed to address and what the traffic needed to be based on the user load coming from those environments. For the ones that we couldn't just flip a switch and increase the traffic, we were able to reroute a lot of it. One particular customer that implemented this was able to reroute their YouTube traffic through a slower pipe, and SharePoint load time was literally cut in half overnight. It was amazing. People love their YouTube. For the sites that had adequate hardware and just had a large user base, we started talking about CDNs, branch cache, things like that. CDN is a local storage closer to the users. Azure has a very nice CDN implementation now, where we store the static images, JavaScript, things like that, so that we can load those a little closer to the environment as opposed to the dynamic content coming all the way back. Our user items, that should be user, not use, sorry about that. Our user action items, there were real no discernible differences. When we looked at the users, there was so much noise, not only coming from that one individual user hitting 60% of our environment, but we had slow network links at all, that we couldn't attribute slow or different OS versions and different internet browser versions to just those two individual items. We were always able to walk back and say, there was something else happening on a lower environment or on a lower tier. Network traffic, the slow websites, things like that. To summarize it up for Contoso, we were telling them that they needed to add some RAM. Went back, said everything you got, you need to double it. Web front ends, app servers. SQL Server was pretty good on RAM, but we needed to turn on some temp databases, and all of a sudden RAM started getting eaten up pretty quick. We had to find the load balancer guys. Depending on if you're a load balancer fan, take them out to lunch. If you're not, we had to lock them out, set the firewall, ruin their day for a little bit. Schoolyard justice, right? This site turned out to be some type of reporting site for this particular environment, where if the load balancer detected the site was down, it was supposed to redirect. So we went back to the load balancer guys, told them to turn it off, asked them very nicely to please not run their test and development and all their other little environments against our production, give them the staging URLs and things like that. And then we told them that we were going to create some pings to go hit their load balancers to make sure they were up and going all the time, just for fun. The help desk site went back and looked, investigated their slow pages, streamlined a lot of their web front ends, streamlined a lot of their web parts, took a look at their underlying BCS connections, set up some indexes and things like that, helping SharePoint improve the performance and execute at the end of the day so that the users can use it. We turned up blob cache. I'm a big fan of blob cache. One of my go-to things as soon as I step out into an environment is just double your blob cache. Whatever it is now, turn it on and double it. If I was here 2 weeks ago, you should quadruple it. Then we went and told them, then we stepped back and said we needed to update our search topology and change SQL Server around, turn on set up our 8 different tempdb files, create one search topology, make it a little more efficient, let all the servers access and understand what's going on. We needed to solve our slow links, like I said before, turn off the YouTube, turn off the cat pictures. While they're great, do it at home. Consider CDNs. Most important bullet here I put down at the bottom. Performance analysis is not a get in and get out type of situation. It's something you have to constantly adjust, reassess, and repeat on a regular basis. Depending on what's applicable for your environment, it may be monthly, it may be quarterly. The idea is you want to run performance analysis frequent enough that you can address any changes happening in the environment before they become critical problems. We are running just a little quick, but that's okay. So in summary, performance analysis is really about understanding what's happening on the end user's perspective and correlating all of your metrics to get to that one way or another. Utilizing the performance pyramid allows us to break out each individual area, set up tools, build logs, and understand what's happening. Ladies and gentlemen, that's it. Please, if you have any questions, let me know. Step up to the mic. Yes, sir. I'm sorry, one more time. So the question was, are we able to release any of the source code? The only source code we really used was ETLing multi-thread. That'll be on blogs and on Yammer coming up. The real key is going to be the database. We're going to release that, the build scripts, and the T-SQL to set that up.
The IIS time taken is the combination of the preparation of the response and the network transmit, or how do you separate out those two?
So the question is, how do you separate the preparation of the response and the time taken through the network? The answer is we didn't. We kept them the same because we wanted to infer what was happening on the end user's machine, and that included that included IIS building the response for us and prepping it out.
How's it going?
It's going well, sir. How are you doing?
My question is, during this venture, was it ever considered to use System Center Operations Manager to correlate the supermetrics that you were gathering? So in this case, the APM to look at the performance in the stack, the client-side monitoring ability, which I know isn't compatible for SharePoint. I know SharePoint 2013 is leveraging a redesigned management pack specifically for that version.
Yes. So the question was, did we consider using operation managers in that suite? Absolutely. However, this particular case study was a reactive setup where we went in and said what's happening for the last 2 weeks. Customers are definitely taking these tools, implementing them, adjusting their management packs to take advantage of that. Absolutely, but that's more of a proactive, quick scenario type of thing. This was looking 2 weeks prior when we addressed it.
Okay, thank you.
Yep.
Hi there. Hi. Sorry, I apologize if you covered this early. I was a little bit late getting in the session. Did you talk about the tooling at all and what tools you use to gather these metrics? Specifically, I'm interested if you used the SharePoint Diagnostic Studio, SPDiag at all.
So the question was, what were the tools that we used to gather these metrics? And I have a list of them. I'm actually flipping back to try to get to that.
Sorry, I don't mean you rehash everything.
No, that's okay. So when we started looking at the individual pages, we absolutely went in and looked at the SharePoint diagnostics. But here are all the tools that we use from a macro level. For our server performance, we looked at Performance Monitor. Configuration, we did enum webs and SPS farm reports. We also loaded ULS into a database so we can scan and aggregate it pretty quick. For traffic, it was all about IIS logs. Exported for header and using advanced logging to capture that on the back end. For LAN and WAN, we inferred what was happening based on the IIS logs and the CS and SC bytes coming back and forth from the user. And then we ran trace routes against the web front ends back to the clients.
Thank you. Do you have any comments about SPDiag, or have you used it at all?
I'm sorry?
Do you have any comments about SPDiag, the Diagnostic Studio?
Do I have any comments about SPI?
Yeah, like recommendations, good, bad?
Yeah, absolutely. Let's take that offline.
Sure.
Let's come chat with me afterwards.
Hey, you talked about blob caching. The way you remediate is by adding more RAM, right?
Yes.
Is it not the blob caching stored on the file system, and when you hit the web front end, it's not stored on the memory?
Yes, you're absolutely right. Cache is stored on the web front end, but the page load times and the page blob that saves a render of the page is definitely impacted by RAM. So by increasing the RAM, we're freeing up what the server can do, and it can interact with the cache a little bit better.
Okay, thanks.
Yeah, I was just wondering, from start to finish, I know you said you captured data for 2 weeks. How long did the actual process take to analyze the data and get all of that back?
So the question was, we captured data for 2 weeks. How long did it take us to actually analyze it? We went through 2 or 3 iterations trying to get it to load quick enough, so that took a couple of days. All said and done, once we had the data back, using the latest version of the tools, it took us about 4 days to analyze it, get it into the database, and then slice and dice and understand what was happening.
Very cool. Thank you.
You said in this specific example, you didn't get any meaningful data out of the user level of the pyramid. Were y'all able to go back and reassess, or another example where you did get something usable out of the user level of the pyramid?
Yes.
That you could do?
Yes. So the question was, we didn't get any discernible differences based on load time on the user tier, looking at user agent and the IP to GPS. Really what happened is all of the slow and poor performing pages, we were able to correlate to other issues existing in the environment. I've had 2 or 3 customers now that have done this, adopted this process. The 3rd or 4th iteration, once SharePoint starts smoothing out and things start working a little better, then we start seeing things where like XP is loading quite a bit slower than Windows 8. Looking back, we can kind of infer that it's the newer hardware that's actually running better, maybe not necessarily XP. Comparing the latest versions of Internet Explorer is going to run better with current versions of SharePoint. Those kind of things, they absolutely start bubbling up, and then we can report that back to users and say, your performance compared to the guy sitting right next to you is worse because you're running Windows XP, and here are all the requests coming through. Yes, sir.
All right. What you said double the blob cache. What's the recommendation on the size of the blob cache?
So the question is, what's the recommendation for blob cache? Pretty much as big as you can get it. Depending on your environment, I think out of the box, it's what is it? Yeah, it's 100 megs out of the box. Turn it up as high as you can get it. You're eventually going to reach a point where you're running out of RAM. The web front ends are either going to need more RAM or they're going to be underutilized on blob. So you just step it up slowly into what makes sense for your environment. For this particular, for Contoso, I think we got it up to 800 megabytes before we started noticing performance segregation because we were eating up the RAM again. But they had boosted their RAM up to 24 gigs before we left. So.
All right, and I've got another question. If you have a worker process that's way up using the processor, what would you use to troubleshoot that?
So the question is, if I had a worker processor that was eating up a lot of process utilization, what would I use to troubleshoot that? My knee-jerk reaction is something like Procmon or something like that. But I would come back and understand what's happening here. Taking a look at that processor, we can quickly see in the performance logs, rolling up in traffic, we can understand what's happening. It may be something as silly as a solution that's getting out of control or an individual page. Using these strategies, you can correlate each time that worker processor is getting out of control and break out and see what's happening and then identify your patterns.
All right, thanks.
Yeah, absolutely. So what he said is using the usage tools, you can actually turn on in the logs how much individual CPU usage each request is taking. My only thing against that is that it's looking at the micro environment. You're not able to correlate what's happening with the rest of the... True. Yes? So, I'm sorry, I can't hear you.
Okay, can you hear me now?
Yes.
Okay, what optimization techniques you use that it wasn't covered in the session to load large files and many files with, to improving the storage with SharePoint?
Okay, so the question is, what were the strategies we used to handle large files? Are you talking about the 400 gigs of data?
No,
or
I'm talking about downloading, uploading large files by users, where
okay.
they store, say, their videos, and they store all the presentations with the screen prints and, their large files. what technique did you use?
So let's take that offline. Come meet me up here so we can kind of talk about the different needs, because there are different approaches you can take for each different file. For example, a video type of environment, you can go as far as a media server and just using SharePoint as a presentation and offload those storage concerns. But if you have something like AutoCAD files or some kind of giant Photoshop documents, things like that, then it might be a little better to keep that in SharePoint, leverage your RBS along those lines. So come talk to me afterwards and let's discuss that in detail.
Yes, how were the server backups or database backups, were they affecting at all in this outcome of?
I'm sorry?
How were your backups affecting the overall performance? That's something we face in our
So our backups were getting affected. Let me bring up and tell you right where that's happening. Here it is. So this right here, this third spike on network activity, this was SQL Server backups happening during essentially business hours. Even though it started at 5:30, we still had a lot of West Coast and Mountain Time users accessing the environment. This particular backup correlated to this guy right here. So where average load time spiked right around 7:30, right around 5:30, 6 o'clock, even though the amount of sessions were driving down, this was a direct impact because SQL Server was starting to back up. So we were able to tell Contoso to postpone that until well after 10 o'clock at night, so we're not impacting those West Coast users.
Hi. I have an environment similar to the one that you're talking about. You mentioned that some of the sites had a lot of parts that were closed but not deleted.
Mm-hmm.
Is there any tools that you know of that you can actually scan an environment that has like 16,000 sites and see what parts are closed and not deleted?
So you can use PowerShell. PowerShell will tell you the status of the web part pretty quick. Enum web parts will also tell you what's happening on the individual webs and if they're having those web parts. So if you know ahead of time what your web parts are, but if you're looking just straight, I want to have closed web parts, PowerShell is going to be your.
And on 2000.
But that's not supported. Yes, so we won't record what he just said.
No problem. 2007 environment, or is that applicable?
No, so 2010. 2007, you're really looking at the object model. To identify if it's closed, I believe the status is what you're looking for on the object model. But yeah, 2010, 2013 PowerShell, SharePoint 2007, you're really talking C# type solution to find that.
Thank you.
Yeah, you can cheat PowerShell in 2007. But.
For one of my customers, SharePoint is throttling the HTTP requests, and it throttles for like 45 seconds, during which time no user can browse any pages. Why would HTTP throttling happen? And when I looked at the logs, I don't see anything other than saying that SharePoint is throttling the request, that's all. So
SharePoint is randomly throttling the request?
Yeah.
Is it to the same page all the time?
No.
No, it's to just random pages?
Yeah.
So that's very difficult to answer without having any evidence.
On the web front ends?
Yep.
Okay.
Yeah, at the end of the day, looking at your throttling is really addressing the symptom, right? Asking why are we throttling, that's not the question you want to ask. You want to ask what is happening that's causing your throttling. And this type of solution is going to be able to identify where that is.
So the second reason that you mentioned is 500 concurrent requests. I cannot control that, right? I mean, we cannot control concurrent requests. Okay, thank you.
Hello. We have 3 front ends, and 2 of the 3 front ends are running distributed cache.
Okay.
And we attributed, 2 of the 3 were also using a lot of RAM. It was almost like 99% RAM utilization. And we kind of attributed that to distributed cache. Is there a way that you can, what's the proper configuration for that? Or
So how much RAM did you have that it was eating up?
24.
24 gigs?
Yeah.
What was your user load?
I'm new to SharePoint. So.
Okay. So if you had 24 gigs, the next question that I would ask is I would start looking at traffic to understand. It might be distributed cache, but going back, that's still just a symptom. You may need to start asking yourself why your distributed cache is so big. Go back and look at your traffic to see if maybe you have a particular page that is being hit quite a bit. You need to make it a little more efficient. But without having the raw logs, it's hard to understand. Okay. Definitely look at traffic, look at server performance as well. Make sure it is distributed cache, what you think. Yep.
Okay. Okay. All right. Thank you.
Yep.
In your analysis and the results, you showed average response time. Did you focus on preparing a response curve and see what outliers are? Our farm, most everything returns in 300 milliseconds. However, we've got to taper down where every day we've got 50 to 100 hits that take 30 seconds and have no idea why.
Yeah, absolutely. In this particular graph, here we go. So we built a graph similar to this for standard deviations, which is what you're talking about, built a bell curve to see where we were. Using average, you're right, it certainly does hide a lot of the outliers. For this presentation though, that's how we set it up. For Contoso, we absolutely went through and identified where that standard deviation was to make sure that our medians were matching to what our averages were, and they were pretty close. So we had a couple guys that were way off the charts and went and spoke to them, and it was silly things like old hardware running on iPads and things like that. The slow original iPads just took a long time to load the page. So the database allows you to do that. This particular slice that for this presentation, we just didn't show that. Yes?
Didn't you got any problems with memory leaks after disabling the automatic application pool recycle?
So the question is...
I saw many solutions which are farm solutions which are deployed, and they're using some third code which has got memory leaks.
So the question is, did we notice any memory leaks after we disabled the automatic app pool recycle? It's my firm belief that the app pool recycle is really just a band-aid to address what's happening underneath the covers. SharePoint is pretty good about not having those memory leaks, especially 2013. It does a great job of cleaning up after itself. For Contoso, we didn't have any farm solutions. We really just had servers that were scaled incorrectly and too small to handle the user load, and it ate up memory as it was supposed to. When we disabled app pool recycle and we increased the RAM to 24 gigs, the web front ends ate about 18 gigs of RAM and have been steady for the last several weeks since last time I talked to them. So. Yeah, absolutely. So to echo that, SharePoint likes its RAM. Really want to keep RAM. He said 1 gigabyte. I prefer 2 gigabytes. If nothing else, RAM is really cheap. You can buy 60. Well, I put 32 gigs of RAM in my laptop 2 weeks ago for less than $200. So to say or to try to micromanage your RAM, anything less than 10 gigabytes, I think is silly, and it's not cost effective. Just the amount of effort you're going to have to go in and make the case to say I need 12, 16, 32 gigs of RAM. I mean, it costs the company, what, $100, $200? It's going to cost them more for consulting to come out and tell them that they need more RAM. Yes?
Hi. Every time we've turned on Blob Cache, we've had an issue where users will upload new images using the same file name, and it's not properly getting stored in the cache. So you'll view the image, it'll be the old image that was previously stored. Is that by design, or is that just a misconfig on our part?
So the blob cache is not getting updated when you change the page around.
Well, if you, let's say you have an image called logo.png,
Sure.
you upload a new version of that image where the image is different, but it's still called logo.png. You'll click on that image, it'll load the old version of it because it's being rendered via
Right.
the blob cache. So the only way we fix it is just turn it off.
So let's take that offline. There's a guy you should probably talk to. He specializes in the WCMS that can tell you all about the TTL and how the blob cache happens underneath. A little smarter than I am on that side of it. I'll give you his name and ask the experts. I think it's tomorrow. He can probably tell you right off the top of the head what's going on and why.
So until a white paper comes out that kind of explains how to do this, do y'all recommend any like APM solutions to help bridge this gap if you don't have a team of performance analysis experts, breaking all this down?
So the question is, when are we releasing the white paper for this?
That's one question. And if you're a big enterprise, do you recommend any APM tools that bridge this gap that will tell you like maybe hotspots and web parts and things like that?
Yeah, so for the APM tools, I really can't make that recommendation. There's a lot of good stuff. Obviously, we have the Microsoft suite that you can customize and tweak to do what you want. Before we release the white paper, this particular presentation will be on Yammer in the next probably 24 hours or so with this recording. And then all the code and deployment that we did will either release to the SharePoint conference site or I'll put it out on my blog for you guys.
I guess I have a question for you or any of the really smart people in the front row. My question is that we had a problem with response time, and instead of going through an in-depth analysis, we were just kind of being reactionary. We started to play with the worker processes at the web application level because we noticed that the WFEs, they weren't really utilizing the RAM. So we started threading that out, trying to use like a worker process per core, per web front end. So I guess just a general question, do you ever play with that? And have you seen performance or throughput and response time based on that? 100 worker, I'm talking about worker processes per application pool. The default setting is 1, right? So we have 8 cores on these WFEs. So we threaded that out to 8, then we scaled back to 4, just so we can maximize the utilization of RAM on the web front ends. Just wondered if that's a practice that you've looked at, and have any thoughts on that?
So the fact your worker process is not eating up or is not using the memory that you think it is or that you think it should be is kind of a concern and where I would start looking. I've seen worker processes eat 20, 30 gigs of RAM, no problem, a single worker process. It's multi-threaded under the hood already, so spinning up additional worker processes may not have the performance boost that you're looking at.
Okay.
Right.
Let me rephrase maybe a simpler question. Do you ever adjust that value, or do you leave it at 1, or is it a common practice to leave it at the default values in IIS? It's an IIS setting. Yeah,
so I always leave it at 1. I've never run across a customer where I advise them to turn that up.
All right, thank you.
But come to the Ask the Experts. I'm curious about why you turned it up, and let's dive down into it a little bit more.
Yeah, we're running load tests with Visual Studio 2013.
Okay.
So, go ahead. No, this is actually a 2013 environment running on Azure virtual machines. So yeah, maybe we can chat after and we can talk about some of that. We were able to load it up. We're just doing a performance comparison against our current on-prem environment running on-prem and the environment that we're building in Azure IaaS. So that's what we did. But cool. Thank you. Worker processes per application pool? Yeah. Yeah. Right. seems like the overall consensus in this room is that nobody here does that. So maybe we can
I agree.
So maybe we could touch base after, and we could kind of think our scenario around that. I can tell you that it did improve our metric, but maybe it's fixing something else under the scene that's happening.
Maybe. And Azure is a little bit of a different beast, too.
We found some interesting things with that, with performance tests.
Yeah.
It's obvious that we're on a shared infrastructure, but and maybe we're trying to do a little compensation on that as well. But thank you.
Yep.
Hi, just a general question. I saw your very large laptop, certainly by UK standards, and I just wondered why in this, we're hearing all about the cloud, you didn't go for using Azure IaaS based Hyper-V to do your analysis on rather than using a big laptop. Just wondered, was there a TCO, or was it just someone gave you a nice laptop? Or
so to sum her up, the question is, why did I use a laptop instead of Azure or some of the other things? To be blunt, because it was cheaper. I had the laptop already.
Okay, that's fine. It's TCO. Okay.
So I didn't see anything about developer dashboard or Visual Studio testing.
Yeah, so Visual Studio testing was in there. Yep, absolutely.
Was Contoso running on physical SQL Server?
I'm sorry, 1 second. So here's Visual Studio testing and where some of the gaps were. This is Visual Studio 2013 running this test right here. Developer dashboard, along the same lines as having the browser sniffers and things, it's really micro-analysis of what's happening on one page, and it doesn't take into account what's happening on the server or what any other cross-site traffic is. So still very powerful, very critical tools, but for a performance pyramid or a strategy like this, they have one particular place, and you probably want to look at other items before we start getting that deep.
The other thing we've used very successfully is Visual Studio testing for a collection of synthetic transactions which we repeat every minute.
Yep.
And get a long-standing curve of performance.
Yeah, absolutely. So replaying IIS logs, yeah, absolutely. Very powerful and works great. Yes, sir.
Contoso was running on physical SQL servers, or was it using virtual SQL server?
Yeah, so these are all physical SQL servers.
Okay. What's your recommendation for the guys who are running on virtual SQL servers like SSDs or RAID 5, RAID 10?
So if you asked me 3 years ago, I would have said you're crazy running on virtual SQL servers. Now all the hypervisors are getting mature enough that the performance cost just running on virtual is in the single digits, what load tests are showing. So my response to you is, for your physical SQL servers, just follow what's happening on TechNet, continue to address your performance like they were physical machines, with the only caveat to make sure that you are load balancing across your individual hosts. You obviously don't want to put you don't want to put a virtual SQL server next to all 4 of your virtual web front ends and then be surprised when the processors are getting overutilized.
So I have a recent scenario where we are building 25,000 document libraries using client object model from a dynamic CRM system, and that brought down the storage, had some issues with the storage, and because they were using flash storage for the SQL servers. Just to bring the perspective.
Yeah. All right, so it's 5 o'clock. I'm happy to stay here and talk a little bit more. I don't think we have somebody else. Sir, if you have one more question, we can talk. No? Okay. All right. Thank you very much.